Hi everyone. I guess I'm the last person standing between you and the beers, so I swear I'll try to keep the time. And yeah, this is the last talk of the day. You must all be exhausted and happy to go on the weekend after that. So we're gonna have some fun. We're gonna play some games. I swear it won't be boring, or at least I will try. So yeah, you've seen the title of the conference. So I've kind of built as a side project a super efficient deepfake detector. And we're gonna go through all of that, through what that kind of deepfakes are, how we can train machine learning models to do that kind of stuff. And also, yes, okay. And also, well, kind of a bit of a more scary story, how I built like a country scale facial recognition software in just like a few days. All right, making sure this is working. So I'm Mathis Hammel. I'm from France. I live in Paris. I work at Coding Game. So maybe some of you have heard of Coding Game already? By show of hands. Yes, there's always one. Thank you. Oh, 3. I have stickers for you if you come see me after the talk, actually. Just quick word about Coding Games so I can get them out of the way. They're paying for the trip, so gotta give them a heads up, and then we're fine. So we are a free platform, so no ads, no paid or whatsoever, to learn programming, learn algorithms by playing games. So actually your code plays the games, and so you try to learn algorithms to solve games better. So this one is a fun one. I played a few days ago about you have to stop a fire from spreading in a forest by cutting the trees faster than the fire and containing the fire. So it was kind of fun. So our actual product is this. So it's a software assessment tool to assess developers. So you don't want to, for example, spend too much time like reviewing hundreds of CV, meeting in personal interviews, each one of them. So you send them automated tests, and we test their skills, not their CVs. So that's a bit of the motto. And if you've heard also of CoderPad, which is an American company, we've recently merged with them. It's an IDE. To basically conduct whiteboard interviews, to put them in quotes, but in an actual IDE. Well, now that we're done with that, we can get going with the actual talk. So this is a website called thispersondoesnotexist.com. It also comes with a much nicer variant, thiscatdoesnotexist.com. Which you may not know. So who knows this website? This person does not exist? Okay, we have already a good base. Don't worry if you don't. I'm gonna explain that. So it's a website. Basically, when you refresh, every time you refresh, you're gonna have a random person, a random picture. This is completely generated by an AI. Well, as we can see with that weird guy on the left, it's not always perfect. Yeah, kids sometimes. Keep this tab open, actually. So yeah, it generates very realistic human faces. So I've put a few of them, a few of those faces. So those faces have been generated by a neural network, except one of them isn't. One of them is a real person. Wanna play a game? Okay. It's better like this, right? So who thinks the real person is on the top left? Okay, a bit of a slow start. Person number 2 right here, middle top. Okay, a bit more. Person number 3, now usually it's the time that people start raising their hand more. Yes, a bit more, yes. Who thinks it's person number 4 on the left? All right, number 5, 6. Oh, not a lot of support for number 6. Number 7 right here. Okay, what about number 8? Number 9. Okay, so 2 things. First, Athens, you're very good. The right answer was This guy on the bottom middle, the guy smiling with the green background. Yeah, number 8. So many people got that right. It's quite unusual, and you're quite good at it. Anyone saw that talk already? Well, that's the first conclusion. Athens, you're gods at detecting fake people. But also, there's like maybe 20% of you who got that, and the other 80% who got fooled. This shows that machines and, well, AIs can now fool us very, very well. This website, it's used a lot for generating fake social media profiles, and that's kind of the origin of my project. So either for scams, political influence, spreading fake news, there's a lot of people out there who need to make a lot of profiles and make them realistic, make them feel like they are human. A while ago, a few years ago, it was quite hard to do because, well, the name, the email address, everything you can fake, you can generate them, but the face is very hard to well, pretend to be a real person. So either those people as a profile picture, they put like some abstract art or just left the default. That's not very convincing. Otherwise, they used a picture of someone else, which isn't very good either, because usually they pull that from somewhere on the internet and it's easy to find with a reverse search. But nowadays, using that kind of AI, it's super easy to pretend you're a real person with just a few clicks. Another thing is that, yes, so as I said, how do we fight against this? That was the idea behind the project. But thankfully, the network, so StyleGAN2, the neural network that generates that kind of pictures, it's super hard to train. We're going to see how it works in a few seconds. But it's super hard to train, so not many people have their own model at home, and most of the scammers and the bad people out there are actually using that specific website that I've shown you. So, well, if we manage to find a way to somehow hack that website, it would be a very nice thing to fight against that kind of threats. First, let's do a sidetrack on a more educative thing on how this kind of model works, and especially, well, AI from the ground up. So I'm going to explain what a neural network is. This, you may have seen this image a lot. This is a neural network. It looks super complex, and like, I mean, I'm sure, like everyone else, when I first heard the term neural network when I was a student, I was like, yes, so they take like brains or something, they put that in somehow in a CPU or something. No, it's much easier than that, actually. The neural network, it's a model, so it's a mathematical way of doing something that the nature does as well. Here, well, it's how the brain works and how the brain learns. It's actually super easy because, well, you're going to have the circles. I'm not sure I can walk on there. This is basically an addition. This is a multiplication, the arrows. And you do that, so you plug the input on the left, and you get an output on the right. That's how it works in the broader traits, but the way you can train it, it's a bit more complex. You basically refine the parameters, you fine-tune the model, so it performs the exact task you want. But what you have to remember is that a neural network is a series of mathematical operations that does one very specific task. A few examples of neural networks that we are using daily, or that some I have worked on. First, finding a plant species from just a picture. It's if you don't have this app, I strongly encourage you to download that. It's called PlantNet. It's amazingly good. You just scan take a picture of the plant, and it gives you the exact name, the area, the Wikipedia page, and stuff like that. Super impressive. Project I worked on was evaluating car damage from a video for an insurance company, so they don't want to dispatch their experts every time there's like two cars hitting each other, so they wanted an AI to evaluate the damage to see if we need a tow truck, how much the damage will cost and stuff like that. And that's the kind of thing that a neural network can very well do. Another application of neural networks is when someone says those two words at the end of the sentence that I'm not going to say because there's a lot of phones in the room. But yeah, that's a neural network as well, which takes as an input a stream of audio and outputs, well, one, for example, when there's this sentence that's pronounced. And also detecting suspicious network behavior or stuff like that, so detecting for cybersecurity. That's another project I worked on, which was basically detecting compromised accounts. And neural networks worked fantastically on that kind of stuff. And more especially for generating stuff, we have something called GANs. Nowadays, we tend to not use those anymore as much, but they were extremely popular in the years 2017 to 2021. Nowadays, so if you've seen DALI, Stable Diffusion, stuff like that, it's guided diffusion models, which work differently. But still, GANs are very popular and are still very efficient and make super realistic outputs as well. So we have in a GAN, we have actually two different networks that we are going to train to perform two very specific tasks. The first one is the generator, and the other one is the discriminator. We're going to see first the generator. We provide it as an input. We provide it just random data. It's because neural networks are deterministic, which means if you give it the same input twice, it will give you the same output twice. Sorry. And yeah, we want to generate some diversity, so we just give it random data and tell it, yeah, generate some pictures of humans. We're going to see in a second how we actually train it to do that. But we tell it to generate realistic faces. The discriminator, on the other hand, is a network that takes an image as an input and just outputs yes or no. Is this a real picture, yes or no? Real picture, I mean picture coming from the real world, and a fake picture would be a picture coming from the generator. Okay, so now that we have those two networks, so the generator making faces and the discriminator trying to discriminate actually between actual faces and faces generated by the other network, we can train those. So we have the training pipeline. It's set up as a game. Every time we're going to pick either a random picture from the real images dataset or a picture that was generated by the generator network. And we're going to give it to the discriminator and tell it, do you think this picture comes from, well, which side of the pipeline do you think this picture is coming from? If the generator makes realistic enough pictures, it will manage to fool the other network, and so it will get stronger over time, so the generator will get reinforced if it makes realistic pictures that the discriminator cannot detect. And conversely, if the discriminator manages to classify correctly a picture between real and fake, then it will get reinforced in its training. I'm not going into the details too much on how we actually reinforce the behaviors, but basically the parameters, you will change the weights of the network, so the multiplication coefficients, to make it do that more often, the positive outcome you observed. So yeah, in each game, only one of the two networks wins. Either it's the generator because it managed to generate a realistic picture, or it's the discriminator because it managed to not be fooled by the other network. And so over time, both of them get better and better because we reinforce the positive the positive behaviors they do, and we unreinforce the negative behaviors. I was mentioning a few difficulties. So first, the first one is overfitting, which is extremely common in machine learning. It's like the first bias you learn in machine learning. It's called overfitting. Basically, it's that your classifier learns the entire real data set. So for example, here on the right, I've shown you a typical example of overfitting. You have a model where you have to draw a frontier. And on the training data, your classifier is going to, the green classifier is going to perform 100%. On the other hand, the black line will not perform as best on the training data, but on the real world is likely to perform much better. There is also slow convergence. So GANs have usually very slow convergence. That's due to the fact, mostly, that actually if you see the generator, it never ever sees one real picture. It only tries to guess what a real face looks like. If it manages to do that correctly, slightly, it will get better and better in that direction, but we will very slowly teach it just through random guesses, whether or not it's doing good or not, through the discriminator. So at first, at the beginning of the training, of course, both networks are outputting random stuff, so the images look all gray and blurry and weird. And the discriminator just outputs yes or no at random, but over time it gets better. Third issue with training GANs is the computing power needed, so it goes with pair with the slow convergence actually. So neural networks, if you didn't know, for training and classification, they are very efficient on GPUs, but they still take a lot of power. And that's also a very large cost, because nowadays, well, GPUs are either used for crypto mining or machine learning. Not so much for gaming, sadly, but NVIDIA is at least investing in that kind of area of machine learning. There's also a fourth issue called mode collapse. It's very similar to overfitting, but for the sake of time and beers, I will not get into too much detail. All right, so how do we detect GAN-generated images? Because, well, that's kind of why I brought you here to talk about. Well, to detect that kind of fake, deepfake images, we could potentially use StyleGAN's discriminator. So StyleGAN is the network that generates the picture. Actually, on thispersondoesnotexist.com, we are only using the generator and not the discriminator. It's just thrown away after training. But if we manage to get that model, which is public, and use that to detect the picture, that could be one way to detect that kind of picture. We could also train our own network, which would take a picture and say, yes, this is real or not. So in a way, code our own discriminator. But actually, if any of those two options were possible, this would mean that we could detect with more than 50-50 random chains images that were made by the network or which were real. So basically, we built a discriminator with good enough performance that we beat the one made by StyleGAN. And I'm not sure about you, but I, by myself, do not absolutely make the claim to be able to make a network that betters than the research team at NVIDIA who made StyleGAN. So we can basically cross them both. But there are other ways. So yeah, GANs are based off a game. So I suggest we cheat now. We have two ways of cheating the game. Either while we find a flaw in the game rules, or we can reverse engineer the GAN, find a property that would help us kind of, watermark that would help us to detect those pictures. And we are going to do both. I'm going to show you two techniques. Let's play another game. So now I'm showing you only two faces, and only one of them is real. Okay, who thinks the person on the left is the real person? Wow, that's a lot. Okay, let's see how many people think the person on the right is real. Okay, so now, you see now you're much better. Yes, it was the one on the left. How is that so? How is that so that here you managed to detect that? Yes, of course, there's a lot of different factors. So for example, the pose, like the face going a bit back with the mouth wide open. Also the image, which is rectangular with a detailed background, stuff like that. Sunglasses, which also we don't see often in this person does not exist. So we have a lot of indicators. That kind of indicators, we have one in particular that I'm going to show you that is very, very accurate. So we have something called the Ffhq Data Set. Oh no, is it loading? Yes. Okay, we'll allow for the conference Wi-Fi. Oh, nice. So those are pictures from the Ffhq dataset. It's called Flickr Faces High Quality, so it's Creative Commons pictures that researchers scrapped from the internet and basically made into a dataset of 77,000 pictures to train neural networks, for example. And StyleGAN2 is trained on this specific dataset. So, I'm not sure if you noticed detail in the previous video. I'm going to show it again with an added overlay. Sorry for the cursed picture. The render isn't that super friendly, but you can see that there's something. Well, the picture is square and everything, but the face is always centered with the eyes at the same position. And that's a property of the dataset. So, well, StyleGAN2 is trying to imitate that dataset. It's trying to fool the discriminator. So it has to put the eyes at the same place as well. Otherwise, the discriminator will find it super easy to tell whether or not a picture comes from Ffhq or the generator. So I can show you in real life. Every time I refresh, you are going to see the eyes are in the exact same place as well on thispersondoesnotexist.com. So this is a good first predetector. Well, this is not a new technique. It's been known for a while. This is not mine as well. But it's a good pre-indicator. Some people ask often like, yes, but like that's pretty much the standard pose in a profile picture, isn't it? Well, actually, I encourage you to go on Twitter or Facebook and try to see how many of your friends have actually their picture with the eyes at this exact place, and it's actually quite rare. Usually people are much, well, unzoomed in the background. Here the face is very, very large in those pictures. So, that's the first technique. Then what we can do is also reverse engineer the GAN. This one is a property of the specific website that I discovered a while ago. So let me show you a script. On the left, you have a script that basically downloads the picture from this person does not exist. It downloads it in a loop and prints just a few first few characters of the picture hash. And you can see that we are going to have duplicates. So here the first one is alone, but the next two ones are identical, which means that actually the server sent us back twice the same picture. It happens again, we even have it 3 times near the middle of the render. So what we can see is that we are going to have the same image given back several times. I was wondering, is it like a local cache thing? So I tried like on 2 different browsers while hard refreshing between heights. I tried from 2 different servers with 2 different IPs. Still, the images were the same. And actually, what I noticed is that it's kind of a global cache. So it's, I think, mostly for the server purposes to not generate like 1 image per request, because it would be a lot. Especially during like spikes of traffic, it would cost a lot of CPU in the cloud to the owner of that free website. So they decided to just have 1 machine that generates in a loop new images every 1.2 seconds and serves them globally to everyone. And well, that's a huge win because it means that there's a finite set of images generated by that website. And we can, well, download them all. And we have a copy of that entire set. So when someone tries to use a picture from the website, we can just detect whether or not it's in the set. So, yeah, if there existed someone crazy enough to have a hard drive to store all those images, yeah, that would be fine. And I am that guy. So, yeah, what I did was basically write a downloader script. The code is pretty much what I've shown you 2 slides ago. So it's like a while true loop and downloads it to the hard disk. 50 images per minute, so if you have good enough connection, it's fine, like it's 30 megs. No, it's not 30 megs per second. That's why sorry. But it's not a lot of data consumed. And I just store it in the disk. And then when I want to find out whether or not suspicious profile picture is real or not, we can just search it on the disk to make sure that whether or not it's in the database. So this looks easy, right? Well, yes, but actually that's a bit more complex than that. So to find out whether an image is in the dataset or not, we have to, well, either use a cryptographic hash, so MD5, SHA-1, stuff like that, in an index to find out very fast and without a lot of data. But the thing is that social networks will compress the pictures slightly for a profile, so we cannot use an actual hash to do the checks. So we will have to do some sort of visual matching, so storing all the images in the disk and going through all the images when you try to find whether or not it's real. And actually, given the scale of that, if I were a company or a government, I think that would pose absolutely no problem. But as I was saying in the title, I only have like $100 of hardware that I have to allocate smartly. And with an image volume, a raw image volume of 11 terabytes per year, excluding any indexes or databases, that's too much to process. So we have 2 issues. Well, the storage space, because I don't want to go to the supermarket, buy a new hard drive every few months. And also the lookup time, because when I want to search an image, I want it to be instant. I don't want to go check for every image, find a visual match or stuff like that. So we'll have to solve those 2 issues. And we're going to kill 2 birds with 1 stone here. Yes, so that's the hardware I'm using. It's called the Jetson Nano. It's basically a Raspberry Pi with a GPU on top to do machine learning experiments. It's super nice, actually. So it's pretty much the same specs as a Raspberry, but with a small GPU on top, which we can use and we will use in this project. So I've discovered something called FaceNet. It's basically a neural network that takes a face as an input, so an image of a face as an input, and it will return a vector of numbers. We can consider that vector to be a hash, the hash of your face. It will make sure that 2 different pictures of the same person, regardless of the conditions, so regardless of the pose, their age, they can be like slightly older or younger in the 2 pictures. They can have different clothes, background, everything like this. The hashes will be identical or very similar. And in the other way, if those are 2 different persons in the pictures, it will make sure that their hashes are very far apart from each other. So it's basically a signature of your face. And having that, we can actually build a system where you can compress the pictures, keep only their hash, the hash of the face, and still have it be a good indicator of whether or not 2 pictures are the same. And to find very quickly in an index if a face is present or not. So yeah, one vector, so one hash is only 2 kilobytes, so that's a very strong reduction in disk. And it's also fast since we have a GPU and neural networks are very fast to be run with GPUs. By the way, FaceNet can be downloaded for free on the web. I didn't develop the model myself. And I think, yeah, the scripts, I will give them at the end of the talk. So for the lookup of the hash, we will have something called Elasticsearch Open Distro, which is basically fuzzy search, so approximate search on vectors. This means that instead of indexing like documents with text and stuff like that, we will just index the vectors, and when we want to find whether or not a face is in the index, we will simply give it the vector as well to match. So the structure, the architecture of the project is pretty much the same, but now instead of directly storing the image, we are storing the FaceNet hash in Elasticsearch database. And when we want to find out whether a face is in the index, we will use an Elasticsearch query to find it in there. For also kind of resilience and verification purposes, I do not store only the hash. I store also a very compressed version of the image, so a very small one, which is also around 4 kilobytes. So this still doesn't use a lot of disk, but allows for visual verification, which is very nice. Because now when we pull, for example, the top 3 faces from the index, we can also show the associated picture, which will be quite blurry, but it will give a strong indicator. I'll show that in an instant. So first bonus point is that since we are using FaceNet, the whole technique is resistant to evasion techniques. So for example, if the scammer or whatever your enemy is, for example, flipping the image or rotating it slightly or cropping that, well, the hash of the face will still remain similar, so we'll still find ways to find that in the index, and it will still be a strong match. Second bonus point, which is also very nice, is that, well, each face appears on the website only once. I've tried on millions of faces. There's no duplicates at all, which means that when we have a positive match in the index, we can also get the exact time it was generated, because in the index, in addition to storing the hash and the very small picture, I'm also storing the exact time at which it was downloaded. So now, if you have, for example, an adversary, a group of fake profiles that kind of share the same messages, and you want to do attribution and group them together, make sure that they are owned by the same person. Even if the accounts were created weeks apart, you may see that the profile pictures were actually generated maybe 5 seconds apart from each other. So that's a very strong indicator that those accounts are owned by the same person. Yes, so it's demo time. All right, 2 things, 2 disclaimers. First, you will see why I am not a front-end developer. And second one, this is likely to crash very badly, but you'll have to trust me. So yeah, this is the interface. Please don't laugh, I'm not a front-end engineer. So yeah, that's the interface. So what I was showing in the slides right here, so that's the part on the right that we see right here. It's called Fada. It's a French reference to an alcohol. So let's generate a random picture. Okay. Let's take another one with, yeah, sure, this guy will do. I'll save that to my disk. So this is live. This was generated just like 2 seconds ago. The pictures are indexed in real time. So there's around 3 seconds between the time they were generated and the time they actually are searchable in the index. So this shouldn't be any issue. Oh yes, it works. Woo! Wait. Oh. Yes. Okay. So it works. so here it will show us the top 3 matches. It's taking quite a long time, but I think it's the slow Wi-Fi. But you can see here we have the top 3 matches of the face I just uploaded. On the left is the very compressed file, so it's only 4 kilobytes. The difference of size between those 2 images are around 4 kilobytes to the left and 400 kilobytes to the right. So there's a lot of compression done. But this gives us a confirmation that this person would be deepfake. Also as a confirmation because, well, this index only works to detect faces that were generated while the script was running. So just in case the script was down or if it was before 2021, I've also included the laser eyes overlay just to make sure. So yeah, that is FADA. Okay, I guess I'm already a bit over time, but we only have 2 or 3 slides left. So yeah, if you want to give it a try, it's free. You can access 15 million faces. Yeah, 16 million faces already. So it's a bit scary to have a country scale facial detection software running on a super small server, but it was a fun experiment to do. And yeah, sub 10-second search, let's say. So yeah, and it's also open source if you want to take a crack at this disgusting Python code that I made. Feel free to do so, and you can even deploy your own at home if you're crazy enough. Lastly, so I gave you a good discriminator, so a good way of finding out whether or not the picture is real or generated by a neural network. Remember the GAN notation? So now let me give you a good generator, so a good way of generating those pictures. So StyleGAN2 is, as I mentioned, it's hard to train, but you can download the open source models for free. And I realized recently that actually TensorFlow 1.x isn't supported anymore on my platform. But you can download this notebook on your system and it will run like a charm. So basically what we do is we clone the repo containing the model of StyleGAN2. And then we can generate faces arbitrarily. So here I have these faces associated to a seed that I've written here. So this face has been generated locally. Well, it was on Google server here, but you can generate it locally. And well, since it's not from thispersondoesnotexist.com, my detection technique goes completely away and you can completely dodge that. All right, so lastly, bonus points. You can also generate variants, so have several pictures corresponding to the same person. This, so I have an example here. With the guy now, he's slightly smiling just before he was not. This is due to the fact that neural networks have a property called continuity, which means that if you modify the input very slightly, the output will also not change so much. And so what we do here is we take, you remember the random data that we provide to the network, to the generator? Well, we just change it a tiny bit, and it will generate some faces. So some parameters will have an impact on the age, on the pose. Sometimes we can even make glasses appear or stuff like that. So if you own a fake social media profile, I hope you don't do that for nefarious purposes, but I'm not responsible for that. Well, you can have way more than just a single picture to build your identity around. Thank you so much, and well, now I'll take any questions if you have, and if you're shy, I'll be around with the beers as well. Thank you.